So we have covered what we're going to do in case we have right angle triangles, right? A quick recap. For right angled triangles, if only lengths are involved, then we can apply Pythagoras theorem. H square is equals to a square plus b square, where h is the hypotenuse, the longest side of the triangle, basically the length or side which is opposite the 90-degree angle. And in case the angles are also involved, or even if only lengths are involved, we can use trig ratios, which are what? Sine theta, which is equal to p over h, cos theta, which is b over h, tan theta, which is p over b, right? So you need to memorize these three very essential trig ratios. For that, I'm sure now all of us are proficient in labeling the right angle triangle's sides. So the length which is opposite the right angle is h. Okay. The length which is opposite the given angle or the angle that you need to find is b. Okay, so for example, if this was theta, then this length would have been b. Okay, so your perpendicular would depend on the angle given, and then the third side would become b, base or adjacent. Perpendicular is also known as the opposite, base is also known as the adjacent. Okay, so there's this shortcut I've seen in books where perpendicular is also known as opposite, right? So O over H, perpendicular is known as adjacent, A over H, and this becomes O over A. Okay, so some books give this as a shortcut. So ka to a, okay? So if this is helpful, you can use this. So S is sine is equals to, so basically this is what it states. S is equals to O over H. So cos is equals to A over H. Ka, tan is equals to opposite over adjacent. Okay? So ka to a. But I would just recommend, just don't complicate your life, just memorize it. It's not at all difficult. So it's P over H, B over H, and then just remove the H's and you have P over B. Okay? I think it won't take more than 5 minutes to understand and memorize. Okay, now before moving on to the sine and cosine rule in case of non-right angle triangles, I want to cover one small thing, which is area of triangle. So in mensuration, the formula that we use to calculate the area of triangle is half into base into perpendicular height. Right? Okay, now let's assume that this is what is given to us in the question. So this is A, B, C. This is 10, this is 12, this is 45. And the question asks you to find the area of triangle ABC. So area of triangle ABC. Okay, so now if we assume that BC is the base of the triangle, right? What is the perpendicular height from BC? This line, right? But we are not given that line. Second option, let's consider AB as the base. What will be the respective height? it will be perpendicular distance from C. But that is also not given. However, we are given two sides and an included angle. What is an included angle? An angle between two lines which are given, right? So this 45 degrees is an included angle because it is included by the lines AB and BC. ठीक है, अगर हम AC or BC, yeah, AC or CB, right? If we take the lines AC and CB, what will be the included angle? The C is going to be the included angle. Okay. Similarly, if we take AB and AC lines, which will be the included angle? Angle A is going to be the included angle. Okay, so if you're given two neighboring sides and an included angle, then the formula that you can use to find the area of the triangle is half into neighboring side 1 into side 2 into sine of the included angle. Okay, so half into neighboring side 1, neighboring side 1, neighboring side 2 into sine of the included angle. Okay, so which is side 1? AB or BC? You can take any. So we're going to, let's plug in the values. So it's going to be half into side 1 is 10 into side 2 is 12 into sine of 45. Okay, so this is going to give you the answer for this question where you had to calculate the area of triangle ABC. Had the perpendicular height be given, the answer to this expression and this one would be the same. आप area of triangle इस formula से निकालो या इस formula से निकालो, दोनों का answer same ही आएगा. Which formula you're going to use will depend on the information that is given to you in the question. Okay, so this is very important. Keep this in mind and then we will practice questions later where we're going to utilize this way of calculating the area of the triangle. Okay? Okay, now let's move on and to the next part of our topic. What happens if we have non-right angled triangles? So whenever you see a triangle and you have a question to attempt, the first thing that you're going to see is whether it is a right angle triangle or a non-right angle triangle. So if it is a right angle triangle, we're going to apply either Pythagoras or trig ratios. If it is not a right angle triangle, then you can either apply the sine rule or the cos rule, which is also known as the cosine rule. Okay? Now, what we're going to do is we're going to address each one of them separately. First, we're going to learn the sine rule, apply them to a couple of triangle questions, that we're going to learn the cosine rule. And after that, once we've mastered the two, then we're going to see how do we decide which rule to apply and when to apply. Okay, so if you're given a question, how do we decide whether we're going to apply the sine rule or the cosine rule? Okay, but one step at a time. Okay, before we get on with the sine rule, one thing that you need to learn, let's not use red, let's use. Okay, so if you need to learn how to read your triangles, okay, so every triangle has three sides, okay, side 1, side 2, and side 3. right? And every triangle has three angles. Let's label them as A, B, and C. Okay, now each side has a partner angle, and you need to figure out, understand how this angle side pair or partnership is formed. Okay, so if this is side 1, the partner angle would be the one which is opposite to it. Okay, so let's begin with the angle. So if this is angle A, right, the partner side to angle A is 1. The partner side to angle B is side 2. The partner to angle C is side 3. Okay, so you need to figure out the angle side pair in order to apply the sine rule and the cosine rule. We will get to the rules in a minute, but first just understand on finding the angle side pair. So angle A has a pair with side 1. Okay, so this is the angle. The side opposite to it becomes its partner. Angle B has side 2 as its partner, and angle C has side 3 as its partner. Okay, so just like we used to find the perpendicular, the length opposite to the angle was the perpendicular. Similarly, the length opposite to the given angle is the partner, side pair, angle side pairs. So A and 1 are partners, B and 2 are partners, angle C and 3 are partners. Okay, so I hope this is clear, and now let's get on with the sine rule. Okay, what is the sine rule? So sine of A over A is equals to sine of B over B is equals to sine of C over C. And another form to write the same rule is A over sine A is equals to B over sine B is equals to C over sine C. Okay? Both of them will yield exactly the same answers, and you can use any of the two forms of the rule that you wish to. Generally, the first form is used to find, whenever you have to find an angle, you use this form, and whenever you have to find a length, you tend to use the second form. But you can just learn one if you want, just learn one of the formulas, and you can apply it to find the length and the angle. Okay, so if you're comfortable with one form, it is fine. If you want to be efficient and use this form when you need to find the angle, and use this when you need to find the length, you can do that as well. Okay, and how is this applied? Let me draw the angle. Okay, so this is angle A, and what is the partner length for angle A? It is A. Okay, small case A. This is angle B, and what is the partner's length or side? This lowercase b. And this is angle C, the length opposite to it, small c, is this side. So this capital letter sine, these are all angles. Okay, and these lowercase alphabets, these are the lengths. Okay, so let's try a couple of questions to see, to apply this rule, and then we will get into the details of when to use this rule. Okay, so So this is A, B, C. This is 30 degrees, this is 40 degrees, this is X, and this is 15 centimeters, okay? And you need to find the value of X. This is going to be probably a 3-mark question, okay? So you need to show full working in order to achieve those 3 marks. Okay, because we are learning the sine rule, we know that we're going to apply the sine rule here, okay? But once we're also done with the cosine rule, the first thing that you need to see is whether it is a right angle triangle or not. If it is a non-right angle triangle, then you need to see which rule you're going to apply, sine rule or cosine rule. Okay, but we will get to that in a bit. First, let's see. You need to find the value of X. What is the partner angle for X? It is 40 degrees, right? So 40 is partner with X. And what about 30? The length opposite to 30 degrees is 15, right? So 30 is partners with length 15 centimeters, okay? Now let's apply, because we need to find the side, we are going to use A over sine of A is equals to B over sine of B. Okay, so A and lowercase a and B, these are the lengths. So B is going to be 15, A is going to be X. So X over, what is the partner angle of X? 40. Sine of 40 is equals to B is 15. What is the partner side of B? Partner angle, it is 30 degrees. So sine of 30 degrees. Okay, now what are we going to do? We're going to take this sine 40 to the other side of the equation. It is being divided here, so we will take it to the other side and it will be multiplied with the numerator. So X is equals to 15 into sine of 40 degrees divided by sine of 30 degrees. So please enter this in the calculator and you should get X is equals to 19.2836 degrees, which you can round off to 1 decimal place, 19.3 degrees. Okay, let's quickly do another question. Okay, so this is 65 degrees, this is 50 degrees, this is X, and this is 9 centimeters, and you need to find X, okay? Again, before, the first thing to see is whether it is a non-right angle triangle. Indeed it is. And we know that we're going to apply the sine rule because that is what we're doing currently. So let's figure out the angle side pairs. Okay, so 65 has a pair with angle X because it is opposite to it. And 50 degrees is going to be pairs with 9 centimeters, right? Let's write down the sine rule. A over sine of A is equals to B over sine of B. Okay, so what is the value of A? Length, lowercase a and B are the side lengths. So this is X over what is sine of A? 65 is equals to what is B? 9 centimeters. And what is the partner angle? 50 degrees. Okay, so X is going to be 9 into sine of 65 divided by sine of 50. We've taken this expression to the other side. So the value of X that you should get is 10.6 centimeters. Okay, now let's do an example where we are required to find the angle. Okay, so this is 12, this is 18, this is X, and this is 30. Okay, and you have to find the value of X. The first thing to check is whether it is a non-right angle triangle or a right angle triangle. Since it is a non-right angle triangle, and we're going to apply the sine rule. Let's figure out the angle side pairs. So this angle X is partners with this side 18 centimeters. Angle 30 is partners with 12 centimeters. And since we're trying to find the angle, we can use the other form of the sine rule. You can also use this form. It is going to yield the same answer. So it is up to you. Okay. Both of them are going to give the correct answer. Okay. Okay, so sine of angle A, capital A is angle X. So sine of X divided by, what is the value of lowercase a? 18 is equals to sine of 30 divided by 12. Okay, so we're going to take 18 to the other side and we get sine X is equals to 18 into sine of 30 degrees divided by 12. Use a calculator to find the value of this expression. Let's see what we get. So we have sine x is equals to 0.75. Okay, now we are required to find the value of x and we need to take sine to the other side. So what do we do when we take sine to the other side of the equation? What is the opposite function that we have to perform? We have to take the inverse of sine. Okay, so to take sine to the other side, we're going to apply this sine inverse function. So sine inverse of 0.75, and that gives you the value of x as 48.5904. So you can round it off to 48.6 degrees. Okay? Okay, so I'm hoping and assuming that you understand the sine rule now. And you know how to apply it to find an unknown angle or an unknown side or length of a triangle. Okay, now let's get on with the cosine rule. Cosine. So this is angle A, angle B, angle C, and the partner sides A, B, and C. Okay? Now here you need to understand the concept of the included angle that I've touched upon while discussing the area of the triangle, calculating the area of the triangle if two neighboring sides and an included angle is given. Okay, now you can either memorize the cosine rule or you can just understand how it is formed, and that would really, I think, help you apply it to questions. So let's imagine you need to find angle A. Okay, angle A. So cos of A is going to be, what are the two neighboring sides? The sides which will make A an included angle. So it is side C and side B. Okay, so whichever angle you're required to find, figure out the neighboring sides because you're going to square them and add them together. So since we are focusing on angle A, the neighboring sides are B and C. So it's going to be B square plus C square minus the third side, basically the side which is partner to it. Okay, so the square of the neighboring sides will be added. This will be added together. And the third side, the square of that will be subtracted. Minus A square divided by 2 into BC. So 2 divided by 2 into the product of the neighboring sides. Okay, so cos of A is going to be the sum of C square plus B square minus the third side, which is A square, divided by 2 into the product of the neighboring sides, the square of which was added. Okay, this might seem a little daunting, but trust me, it is not. Okay, let's see. Let's formulate the formula for angle B. Cos of B. Okay, this is B. Which sides are the neighboring sides? C and A, right? A and C would make B the included angle. So if we are focusing on angle B, the neighboring sides are C and A. So A square plus C square minus, which is the third side? Obviously B is left, so it is going to be minus B square divided by, what is the product of the neighboring sides? 2 into A into C. Okay, one last formula, cos of C. So if you're focusing on angle C, what are the neighboring sides? A and B, right? So is equals to A square plus B square minus, which is the third side, C square, divided by 2 into product of the neighboring sides, which is A and B. Okay, we use this when we are required to find the angle, okay, to find angles. Now to find sides or lengths, we have another formula, which is basically the manipulation of this very formula. So just like in case of the sine rule, you can use this, use this formula to find the side or length as well. So for example, imagine you have to find length A, okay? So the formula to find length A is A square is equals to B square plus C square minus 2CB over cos of A. Okay, you can either memorize it or you can just simply use this formula. Okay, it is just a manipulation of this formula and I will show it to you right now. Okay. Okay, so this is the formula, right? What are we going to do now? We are going, since we need to find A, we're going to make A the subject. Okay, so we need to make this term the subject. The first thing that we're going to do is we're going to take this 2BC to the other side. So what do we have? We have 2BC cos of A is equals to B square plus C square minus A square. Okay, let's take minus A square to the other side. What does it become? It becomes A square minus A square becomes positive A square plus 2BC cos of A is equals to B square plus C square. Okay, and now because we need to make A the subject, we're going to pick this term up plus 2BC cos A and take it to the other side. It is being added here. So when we take it to the other side of the equation, it will be subtracted. So A square is equals to B square plus C square minus 2BC cos of A. And this is exactly the same formula as this one. Okay. So as a student, to be very honest, I never memorized this formula. I just memorized this one, and not even memorize it. I understood how this formula was formulated. And then, even if I had to find a length, I would just, substitute, plug in values into this formula and then make A the subject. However, I think it is a good idea to, just to save time, you can also memorize this form of the formula, and it can save you, potentially it can save you time. Plus, once you're manipulating the equation, some students tend to make errors, so even chances of that are reduced if you memorize the formula. Okay, now let's practice a couple of questions where we apply the cosine rule, and then we're going to move on. Okay, so this is A, B, C. Let's imagine this is 10, this is 12, and this is 45 degrees. Okay, and they're asking you to find AC. Okay, so let's assume AC is X. Okay, now we need to find X. What are we given? We are given 45, and we're given the neighboring sides 10 and 12. Okay, so let's see. We can either apply this formula directly. Okay, let's copy it to find the length. Okay, so what is a square? In this case, it is x square is equals to b square plus c square. The neighboring sides are basically 10 square plus 12 square minus 2 into cb, which is 10 into 12 into cos of a, which is 45. Okay, so you have to be careful. The angle that you're going to use or in the formula should be the one which is the included side or the included angle. Okay, so had 50 degrees been given in the question as well, so you had to be sure, absolutely sure, that you're not going to use 50 degrees in the formula. Why? Because we are going to use the included angle, the one which has two known neighboring sides, if you're going to apply this cosine rule. Okay, and once you solve this, you get x or AC, which is equal to x is equals to 8.62 centimeters. Okay, however, when I was a student, I don't know why I never memorized this formula, and I would just simply construct the cosine rule that I've just taught you. So this is 45 degrees, and what are the neighboring sides? 10 square, 10 and 12, right? So cos of 45 is equals to 10 square plus 12 square minus the third side, which is x square, over 2 into 10 on 12. Okay, so this is going to give you exactly the same answer. Okay, so you can choose whichever formula you're comfortable with. Just go ahead and employ that. Okay, let's do another quick example of cosine rule. Okay, I don't want this color. Okay, so let's say this is x, this is y, and this is z. This is 8 centimeters, this is 13 centimeters, and this is 15 centimeters. Okay, so all three sides are given, and the question asks us to find angle x. Okay, so you have to find angle x. So let's apply the cosine rule. We need to find angle x. What are the neighboring sides of x? 8 and 15. Okay, so let's write that down. Cos of x is equals to the sum of the squares of the neighboring sides. So it is 8 square plus 15 square minus the square of the third side, which is 13 square, over 2 into product of the neighboring sides, 8 and 15. Okay, and whatever answer, because you need to find the value of x, you're going to segregate cos from it. How? You're going to take it to the other side by taking the inverse of the function. Okay, so it is going to be x is going to be cos inverse of this expression. So first find the value of this expression, then take cos inverse, and you should get cos x is equals to 60 degrees. Okay, please use your calculators to verify the answer. Let's see, what if the question asked you to find angle y? Okay, so let's formulate the formula to find angle y. So cos of y will be equal to, what are the neighboring sides of angle y? 15 and 13. So it's going to be 15 square plus 13 square minus the third side, which is 8 square, over 2 into 15 into 13 Then you're going to take cos to the other side and take cos inverse of this expression, and you should get y is equals to 32.2 degrees. Okay, and let's do it for angle Z. Cos of Z will be equal to, what are the neighboring sides? The neighboring sides are 8 and 13, right? So 8 square plus 13 square minus the square of the third side, which is 15, over 2 into 8 into 13, right? And then Z will be equal to cos inverse of the answer of this expression, and Z should be equal to 87.8 degrees. Okay? Now the question comes, when are we to use the sine rule and when should we use the cosine or cos rule? Okay, so to apply the sine or cosine rule, the first requirement is that the triangle should be a non-right angle triangle. Okay, so you can apply the sine rule only if one angle side pair is given. Okay, so this rule can only be applied if a complete angle side pair is given to you. Okay. The only condition that needs to be satisfied if you want to apply the sine rule is that we have at least one complete angle side pair. Okay, 3 होते हैं, इनमें से एक भी given है, then we can use the sine rule. What about the cosine rule? So for cosine rule, you can apply cosine or cos rule if all 3 sides are given. That's one of the possibilities. Or 2 sides and an included angle. Okay, so the first thing that you're going to check is if we have a right angle triangle or not. If not, then we can use sine and cosine rules. To apply sine rule, you need to check if the non-right angle triangle has at least one complete angle side pair given to you. If it is given, then you can apply the sine rule. If not, then obviously the second option that you're left with is the cosine rule. However, the conditions that need to be met before you can apply the cosine rule is that either all 3 sides of the triangle are given to you, or 2 sides and an included angle. The angle between those 2 sides is given. Okay, so these are the conditions that one of these conditions needs to be met if you want to apply the cosine rule successfully. Okay, so let's try this past paper question to apply these rules. Okay, so the diagram shows a footpath PR across a park PQRS. So PR is a footpath, PR is a footpath across the park PQRS. So this is a park and this is a footpath which crosses the park. PQ is 64 meters, PR is 53 meters, PS is 74 meters, QR is 91 meters. Angle PRS is 68 degrees. Calculate QPR. So let's mark the angle that we want us to find. QPR. Also, this hat notation has now been discontinued, and they write this as angle QPR. Okay? Okay, so the first thing, this triangle is a non-right angle triangle. Okay, so we are either going to apply the sine rule or cosine rule. We need to find this. Okay, so let's check if we have a complete angle side pair. So this angle we need to find. So this is not given. So 91. No, this is not a complete angle side pair. And we're not given any other angles. So we cannot form a complete angle side pair. So then what are we cannot apply sine rule. What are we going to apply? We're going to apply cosine rule. And see, we are given all three sides. So yes, we can apply the cosine rule. Okay. Now, cos of x, let's formulate the expression for cos of x. Square of neighboring sides. What are the neighboring sides? 64 and 53. So 64 square plus 53 square minus the square of the third side, which is 91, over 2 into 64 into 53, the neighboring side. Okay? So let's see, what do we get? 64 square plus 53 square minus 91 square divided by 260. So cos of x is equals to minus 0.20283. Now to maintain the accuracy, keep the answer on your calculator screens. And to find x, we're going to take cos to the other side and take the inverse of the function. So cos inverse of negative 0.20283. Since the answer on the calculator is as it is, what you're going to do is that you're going to insert on your calculator cos inverse answer. Press the answer key. Okay, so that is going to maintain the accuracy. And you get x is equals to 101.7025, and we're just going to round it off to one decimal place. Okay, so we have the answer as 101.7. Okay, it is a 3-mark question, so please make sure that you show all the working very neatly and carefully. Okay, part B. Find angle RPS. RPS, this angle, right? So let's mark this angle. RPS now becomes X. Okay. First thing, non-right angle triangle. Second thing, see if we can apply the sine rule. Okay, so we have 68 and its side pair side is also given, which is 74. So we have one angle side pair. So we can apply the sine rule. Okay, so let's see. 68 degree has a pair with 74 meters, and X will have a pair with RS, and 53 will have a pair with this angle. Okay. Now to find angle X, we need this side, which is RS, and we do not have it. We have side PR, but then we do not have this angle. Okay. And we cannot apply the cosine rule. Why? Because two sides are given, the third side is not given. What is the second condition? The two sides and an included angle is given. So we have 53 and 74, but X is not given, right? And we're given 68, but 53 and the other neighboring side is not given. So what are we going to do? First, we're going to use the sine rule to find the length RS. To find the angle S. Okay. Once we have angle S, so we will have two angles in a triangle, so we can find the third angle. Okay, so that is the route that we are going to follow. Whenever you have a question, think for a moment about how you're going to go about solving it. Okay, don't be in a hurry. Don't just jump onto solving the question. Sometimes you need to think twice and you have to think of different strategies, and then you need to choose which strategy you're going to apply. Okay, so give yourself a moment or two and devise a plan of how you're going to go about solving the question. Okay, so we are going to find angle S first. Okay, so sine of S over, what is the partner length? 53. Over 53 is equals to sine of 68 divided by 74. Okay, so sine of S is equals to 53 into sine of 68 divided by 74. So we have, let's calculate, 53 sine of 68 divided by 74. So sine of S is equals to 0.66406. Keep the answer on the screens and enter this. So sine inverse of the answer that you got is 41.61056666. Keep that on the answer on the calculator screen as well. So this is 41.61. Okay, and we need to find this angle. So angle X is going to be 180 minus 68 minus 41.61 degrees, right? So 180 minus 68 minus, instead of 41.61, you're going to enter minus answer and you get 70.389. 70.389433, and you can round it off to 70.4 degrees. So you're going to round off only your final answer. Okay, you cannot round off the workings. That is going to get an incorrect answer and you're going to lose marks for accuracy. Okay, so this is 70.4 degrees. Okay, the last part, find the area of triangle PRS. PRS. Okay, so this triangle. We do not have a perpendicular height in this triangle. However, we have a formula that we can apply when two sides and an included angle is given to us. Okay, so these two sides are given 53 and 74, and therefore what is the included angle? This one, 70.4. Okay, again, you can keep this answer on your calculator screens and you can utilize this answer when you're trying to find the area of the triangle. So this is half into neighboring sides, which are what? 53 and 74 into sine of 70.4 degrees. Okay, so I have this answer on my calculator. I'm just going to take sine of answer into 74 into 53 divided by 2, which gives me 1847.2533 meters square, which is approximately equal to 847 meters square. Okay, so this is a question where they will never tell you which rule to apply. Okay, so you need to figure that out yourself. So this was a question where we first applied the cosine rule, then the sine rule, and we also utilized this formula for calculating the area of the triangle. Okay, now in order to master these concepts, you need to practice past paper questions because they're obviously going to twist and change questions, and only practice will help you or will equip you to successfully answer questions of different types and natures. Okay, now on to the last part of our topic, supplementary angle identities. Supplementary angle identities. But before we explore them further, I want um, you guys to know what supplementary means. So basically, supplementary angles are those angles which add up to 180 degrees. Okay, that basically sum up to okay. So 30 and 150, they're supplementary angles. 80 and 100 are supplementary angles. 60 and 120, supplementary angles. 1 and 179, supplementary angles. So basically, two angles that add up to 180 degrees are known as supplementary angles. A quick recap. Angles between 0 and less than 90 degrees are known as acute angles. Okay. Angles which are equal to 90 degrees are known as right angles. Angles greater than 90 degrees and less than 180 are obtuse angles. And angles which are greater than 180 and less than or equal to 360 are reflex angles. Okay, so if the question asks for an obtuse angle and the value that you obtain for the angle is acute, then all you have to do is subtract the answer from 180. And if it asks you for reflex angle, then you have to subtract the answer from 360. We will do some past paper examples to attempt such questions. Okay. Okay, so first thing that you need to know and understand is that supplementary angles are angles which add up to 180 degrees. Okay. Now the first identity is sine of theta is equals to sine of 180 minus theta. Okay. It means that what this identity is stating is that sine of 30 is going to be equal to sine of 150. Okay. Sine of 80 is going to be equal to sine of 100. Basically, what are we doing? These are supplementary angles, right? So if this is 30, 180 minus 30 would be 150. If this is 80, 180 minus 80 would be 100. So the sign of supplementary angles is equal. That is the first identity. Okay? So sine of supplementary angles is equal. What about cos? Cos of supplementary angles is equal in numerical value, but it has a negative sign. And same goes for tan. Okay, so tan of theta is negative tan of 180 minus theta. What does this mean? This means that cos of, for example, cos of 30 is going to be equal to negative cos of 150. Okay, cos of 80 is going to be negative cos of 100. Wait, right? For sine, the numerical value and the sign was equal. Okay, so sine of 30 is equal to sine of 150. Okay, cos of 30 is equals to negative cos of 150. Tan of 30 is equals to negative tan of 150. Okay, so basically, this is a straight line. Okay, and this is the acute angle, and this is the respective obtuse angle. So the numerical values of sine, cos, tan for both acute and obtuse angles will be equal in all three cases, but cos and tan are negative. Okay, this might seem a little confusing, but it's a very straightforward and simple, easy identity. And let's practice a few questions to understand how you can be tested on these identities. Okay, so this is a past paper question. Let's see. In the diagram, BCD is a straight line. BC is 5 centimeters, AB is 12 centimeters, and AC is 13 centimeters. And triangle ABD, angle ABC is 90 degrees. Okay, it doesn't look like a 90-degree angle, but it is a 90-degree angle, so be sure of it because it has been stated clearly in the question. Now they're asking you to find the tan of BAC. BAC. Okay, so the tan of BAC, let's assume this is X. Okay, so what is the formula for tan? Tan of X is going to be P over B, right? So let's first label our triangle. If this is the 90-degree angle, so this is going to be the hypotenuse. So this is H. This angle is given, so this is going to be the perpendicular. This is going to be P, and therefore this becomes P. So tan of X is going to be, or we can write tan of BAC is going to be P over B. P is 5, B is 12. So what is the value of tan of BAC? It is 5 over 12. Okay. Part B is cos of ACD. Cos of ACD. Okay, so they're asking you for the cos of this angle. And we have no clue about the angles, right? But we know that cos of BCA is going to be, this is the acute angle, right? And this is the obtuse angle. So cos of BCA is going to be negative cos of DCA, right? This is the identity that we've covered here. So cos of theta is negative cos of 180 minus theta. This is the acute angle, this is the obtuse angle. Now, since this is a straight line and these add up to 180 degrees, both of these are supplementary angles. The question asks us to find the cos of DCA, but we have no idea what this angle is, right? However, we have a right angle triangle, and if we are able to find the value of cos of this angle, the same value with the negative sign would be the answer to the cos of the obtuse angle. Okay? If this is not clear, please pause and listen to this part again so you have no confusions as to how I'm solving this question. Okay, so cos of ACD, cos of ACD will be equal to negative cos of BCA. Okay, now what is cos of BCA? Cos of BCA will be B over H, right? So what is base? Base is 12, hypotenuse is 13. So cos of BCA is 12 over 13, and the cos of the respective obtuse angle would be 12 over 13, but with the negative sign. So negative 12 over 13. Okay, this is where we are applying the supplementary angle identities. Okay, let's do another question very quickly. Use as much information in the table as necessary to evaluate 2 sine of 150. Okay, so they've given us sine of 30 is 0.5, right? And we know that the sine of supplementary angles is equal. So sine of 30 is equal to sine of 150. Okay, so sine of 30 is 0.5, which means sine of 150 is 0.5. So 2 into 0.5 is going to give you 1. So your answer is 1. Okay. Next part. In the triangle ABC, ABC is 90 degrees, AB is 3x, BC is x plus 1, AC is 3x plus 1. AC is 3x plus 1. Okay. Form an equation in x and show that it reduces to x squared minus 4x is equals to 0. Now all three lengths are given and it is a right angle triangle. So what can we use? I think you should have no problem in guessing that we are going to apply Pythagoras here. Okay. But for that we need to label the sides. The length opposite to the right angle is h and the other two are the legs. Okay. So it's going to be h square is equals to a square plus b square. A square is 3x plus 1 square is equals to x plus 1 square plus 3x square. I hope everyone is clear about the expansion of 3x plus 1 square. It's not going to be 9x square plus 1. Okay, we are going to apply a plus b whole square, which is a square plus 2ab plus b square. Okay, so the expansion would be 9x square plus 6x plus 1 is equals to, we're again going to apply a plus b whole square, x square plus 2x plus 1 plus 9x square. Okay, let's simplify the expression by collecting like terms together. Okay, so what are the like terms? So x square, x square, x square, x, x. Okay, so let's collect them together. It's going to be 9x square minus 9x square, or we can just simply, x square plus 9x square would be 10x square, right? So this would become 10x square. We're going to take 10x square to the other side, so it's going to become minus 10x square. Plus 6x, we're going to take 2x to the other side, minus 2x. Plus 1, and we take plus 1 to the other side, becomes 9. Minus 1 is equals to 0. Okay, so this gets cancelled out. 9x square plus 10 minus 10x square would be negative x square, plus 6x minus 2x is plus 4x is equals to 0. Multiply this expression with a negative sign and you get x square minus 4x is equals to 0, which is the same as this expression, the one that we had to evaluate or to prove. We had to show that the equation reduces to x square minus 4x. So therefore shown. Okay, now they want us to find the value of x. So it is very simple. Take x common. You have x into x minus 4 is equals to 0. So either x is equals to 0 or x minus 4 is equals to 0. So x is equals to 4. Since x is the length, it cannot be 0. So what is the value of x? It is going to be 4. Okay. Given that BCD is a straight line, state the numerical value of cos of DCA. DCA. Okay, so we have to find this angle. And why are they stating that it is a straight line? So that you have no confusion or doubt about the fact that this is going to be a supplementary. These angles are going to be supplementary angles. Okay, so this is the acute angle and this is the respective obtuse angle. So let's first find the cos of, let's label it theta. Okay, so what is the cos of ACB? Cos of ACB is going to be P over B. Sorry, that's 10. It's going to be B over H. Okay, so H is, let's write down the values. B, okay, this is for, we need to label the triangle first. Okay, so hypotenuse is the side opposite to the right angle. The side opposite to the angle is perpendicular. And the third one is the base. Okay, so what is the value of the base? It is x plus 1. What is x? X is 4. So b becomes 5. And what about h? H, it will become 3. Value of x is 4 plus 1. So it becomes 12 plus 1, 13. Okay. So cos of ACB is going to be 5 over 13. Okay. So this is the cos of the acute angle. What about the obtuse angle? The question asks us to find the cos of this, right? So we know what the identity is. The identity is cos of theta is equals to negative cos of 180 minus theta, right? So if cos of ACB is 5 over 13, cos of DCA is going to be negative 5 over 13. Okay, so this is going to be your answer. Okay, so one last question before we wrap this video up. In this diagram, DAB is a straight line, BC is 10 centimeters, CAB is 8 degrees, CBA is B degrees. Use as much information given in the table as is necessary to answer the following questions. Write down the value of cos of DAC. DAC. Okay, so this angle, right? Let's label this angle. We know that the cos of this angle is going to be the negative of whatever the cos of A degree is, right? So cos of DAC will be equal to negative cos of A degrees. We know that from the supplementary angle identities, right? Now, what is the value of cos of A? Cos of A, okay, and cos. So it is 4 over 5, right? So it is going to be negative 4 over 5. Next, they're asking you to calculate AC. Calculate AC. Okay, so this is a non-right angle triangle. So either we're going to apply sine rule or cos rule. Sine of A is given and length 10 is given. So we have one angle side pair, right? So we are going to apply the sine rule. So sine of, okay, and what is AC? Okay, let's highlight the angle side pair. So A is this and B is AC. So the pair side that we need to find is AC. So AC over sine of B is equals to 10 over sine of A, right? Now let's utilize the value. Sine of A is 3 over 5. Sine of A is 3 over 5. Let's first make AC the subject, okay? So AC is equals to 10 into sine of B divided by sine of A. Sine of B, let's write down the values. Sine of B is 24 over 25. What is sine of A? Sine of A is 3 over 5. Okay, so let's find the value of AC. AC is 10 into sine of B, which is 24 over 25, divided by sine of A, which is 3 over 5. Okay, what are we going to do? We're going to convert this division sign into multiplication. How? We're going to reciprocate this fraction. So AC becomes 10 into 24 over 25 into 5 over 3. Right? Now let's simplify. 5 ones are, 5 fives are 25, 5 ones are, 5 twos are. 3 ones are, 3 eights are. So AC is 16. Okay? These are P1 questions where calculator is not allowed. Therefore, they've given you the sine and cos values of the angles, and the calculations are also pretty simple. So I hope this question is clear. If not, please rewatch whichever part is confusing or troubling. And if you still have problems, you can drop in a comment and I will get back to you as soon as I can. And that wraps up our video on trigonometry. If you followed along and understood the theoretical concepts, that's a solid first step. But remember, the real magic happens when you practice. It's absolutely essential to go through past paper questions from both the papers, the non-calculator paper and the one in which calculator is allowed. Understanding the theory without applying it just won't cut it if you're aiming to truly master this topic and ace your exam. So please practice, practice, practice. I can't stress this enough. If you're stuck or you have any questions at all, please don't hesitate to reach out. I'm always there to help. I've got your back. And also, if you haven't subscribed to the channel as yet, I'd be super grateful if you did. If this helped things click, give it a like and share it with anyone you think might benefit. Good luck with your exams. Go be remarkable.